Imagine sitting at a lonely sensor station in the frozen expanse of the Barents Sea, 72 degrees north, 38 degrees east. It's February 12, 2025, 2:23 p.m. UTC. Inside this U.S. government monitoring post, a duty analyst sips his coffee while running the usual telemetry checks on the upper atmosphere, scanning for any hint of ballistic activity. His screens glow with the hum of routine, the kind of shift that produces nothing remarkable. Hundreds of afternoons like this have passed the same way, flag log after flag log, data after data, until suddenly, the sensors trip. Something is entering the atmosphere at 72.4 kilometers per second. He checks the calibration, then checks it again. The number doesn't lie. Pinned above his workstation is the velocity threshold table. The escape velocity of our solar system at Earth's distance from the Sun is 42.1 kilometers per second. This object is moving 30 kilometers per second faster than anything gravitationally bound to our Sun. He flags the reading, logs it meticulously, and picks up the phone. Within 6 hours, this event is quietly entered into NASA's CEO Fireball database. Routine atmospheric impact. No press release. No headlines. Just a catalog entry. The Barents Sea, time-stamped and filed. The world doesn't notice. 14 months later, researchers at Harvard rerun 1 million Monte Carlo simulations on that database entry. They factor in measurement uncertainties, atmospheric drag, Earth's rotational effects, and gravitational influences from every major body in the solar system. Every single trajectory, 1 million in total, shows the same outcome: positive heliocentric specific energy, unbound, definitively interstellar. The analyst's coffee long forgotten, the data silently confirms a truth that the world didn't know yet. Something from outside our solar system had just entered it. What makes this moment extraordinary is the timing. That object arrived precisely 139 days before another interstellar object, 3-2 Atlas, was detected entering the solar system. This isn't just a story about meteors. It's a forensic investigation into 4 interstellar objects impacting Earth over 12 years, their timing, composition, and a theoretical framework that forces us to stop calling these coincidences. To grasp the magnitude of the Barents Sea event, you first need to understand escape velocity. Every star generates a gravitational well, a region where objects below a certain velocity remain trapped. For our Sun, that threshold at Earth's orbit is 42.1 kilometers per second. Anything faster carries positive heliocentric specific energy. It's not orbiting the Sun, it's passing through, originating elsewhere. The first confirmed object to exceed this threshold was IM-1. It struck near Papua New Guinea on January 8, 2014, traveling 60 kilometers per second, the fastest recorded meteor impact in history. Declassified U.S. Space Command data in 2022 confirmed its interstellar origin. Later, in June 2023, an ocean floor expedition recovered 850 tiny metallic spherules from IM-1's vaporized remains. Elemental analysis revealed enrichment in beryllium, lanthanum, and uranium in ratios that defied natural solar system processes. Isotopic signatures showed billions of years of cosmic ray exposure, material like nothing catalogued on Earth. Then came IM-2, March 9, 2017, over the North Atlantic, releasing energy equivalent to 3 kilotons of TNT at 31 kilometers altitude. Interstellar origin confirmed. 6 months later, Hawaii's Pan-STARRS telescope detected 1I, Oumuamua, the first large confirmed interstellar object on a hyperbolic trajectory. The timing seemed coincidental at first, but the pattern is emerging, and it's impossible to ignore. Fast forward to CNOS 25. On July 28, 2022, an object exceeded solar escape velocity by nearly 9 standard deviations. Then on February 12, 2025, CNOS 25 impacted the Barents Sea 5 months before 3 Atlas appeared. Monte Carlo simulations confirm every trajectory unbound, every calculation consistent. The pattern mirrors 2017, when IM2 preceded Oumuamua by 6 months. Probability models suggest a 94% chance this timing is not random. In any scientific domain, a 94% probability is massive, yet here it drew rejection, not celebration. Theoretical frameworks, including string theory and the Kardashev energy scale, provide insight. If a civilization could operate at type 2 or 3 energy levels, its reconnaissance across interstellar distances wouldn't resemble a labeled spacecraft. It would look exactly like these objects, small, fast, arriving ahead of a main vessel, either burning up completely or delivering compact payloads to survive entry. The Barents Sea site is shallow, 230 meters deep, accessible with recovery technology proven in 2023 for IM-1 spherules. Yet, a formal National Science Foundation proposal, peer-reviewed with top scores, was rejected. The reasoning? Insufficient evidence of scientific significance. This, despite the fact that no existing meteorite collection contains interstellar material. No collection has IM-1 class isotopic anomalies. No collection could capture a probe arriving months ahead of a massive interstellar visitor. The data and the pattern are clear. The silence of institutions does not negate the reality of what arrived that day, what remains on the seafloor, and what connects to objects like 3-2 Atlas. This is not random. It is reconnaissance, pre-planned, precise, and profoundly alien. The pattern emerging from this dataset is impossible to ignore. 4 interstellar objects in 12 years, 2 of them arriving in perfect alignment with major interstellar transits. The implied population density of these objects is staggering 1,000 times higher than what any galactic models predict. Telemetry isn't a random blip, it's a repeating signature. And in part 2, we dig deeper into what this population density mathematically demands and why scientific journals rejected the conclusions, not the methodology. Let's put numbers to this. Observed impact rates suggest 8.4 million interstellar objects inside a single cubic astronomical unit space, roughly the size of Earth's orbit around the Sun. That's 8.4 million objects, each roughly 1 to 1.5 meters in diameter, packed into space we thought was nearly empty. Within Earth's orbit alone, the total population implied reaches 35 million objects. At a solid density of 3 grams per cubic centimeter, each object weighs around 3 million kilograms. Multiply that across the estimated 35 million, and the total mass is 100 trillion metric tons. To put it in perspective, the entire asteroid belt between Mars and Jupiter, the product of 4.5 billion years of solar system evolution, holds about 3 quintillion kilograms. The interstellar population suggested by just 2 confirmed impacts in 7 years equates to 3% of that belt, invisible until impact. This is where physics pushes into the impossible and institutions retreat into silence. The Milky Way contains between 100 and 400 billion stars. Each star ejects material through stellar winds, supernova events, planetary debris, and gravitational scattering. Distributed across the galaxy, this should produce interstellar object densities orders of magnitude lower than what impact rates demand. Every galactic dynamics model, every stellar evolution framework, every nucleosynthesis calculation converges on the same upper boundary. The density required to explain 2 Earth impacts in 7 years is simply unachievable by natural processes. We are left with two options. Either our understanding of galactic physics is catastrophically incomplete, off by a factor of 1,000, demanding a fundamental revision of stellar mass loss rates, supernova ejecta velocities, and galactic dynamics, or the objects are not randomly distributed at all. They are not debris drifting passively, and they are not fragments ejected over billions of years. Something else is at work. Theoretical models exploring directed panspermia, von Neumann probe deployment, and large-scale cartographic architectures converge on a startling conclusion. A civilization capable of deploying functional interstellar objects at densities sufficient to produce the observed impact rates wouldn't need to launch each object individually. They could seed self-replicating probes or prepositioned assets across gravitational waypoints, using the natural geometry of stellar systems to guide objects toward points of interest. And Earth has been a point of interest flagged, in effect, 4 times over 12 years. The compositional data from IM-1 spherules reinforces this conclusion. Beryllium, lanthanum, and uranium in ratios impossible to generate in known stellar or planetary nucleosynthesis. These elements don't just form naturally. Their creation requires highly specific neutron flux conditions found in neutron star mergers, rare supernovae, or artificially engineered nuclear processes. Their isotopic signatures reveal billions of years spent in interstellar space, yet the material's elemental ratios at formation match nothing we know. The journal submission documenting CNOS 2.2 and CNOS 2.5 was met with resistance. Reviewed in February 2026, one referee deemed it acceptable with minor revisions. The second rejected it, not over methodology or Monte Carlo analysis, but interpretation. The reviewer argued that the high implied population density might merely reflect improved detection capabilities, not anomalous concentrations, but that logic is circular. Better instruments don't create the population, they reveal what was already there, 1,000 times more interstellar material than galactic models predict. The paper was rejected on March 19th, yet the data was public, the calculations were reproducible, the preprint was indexed and available to any astronomer on Earth. The refusal wasn't about evidence, it was about what that evidence implied. Now, consider temporal geometry. 3.2 Atlas was detected on July 1, 2025, at 4.1 AU, deep in the Solar System. Working backward, it crossed Neptune's orbit in late 2024, Uranus in early 2025, Saturn in March 2025, just 1 month after CNOS 2.5 impacted the Barren Sea. If CNOS 2.5 separated from 3.2 Atlas, while the main object was still beyond Saturn, given a small velocity adjustment targeting Earth, its arrival on February 12, 2025, is mathematically exact. The probe either ablated completely or deployed a compact payload, surviving entry to land on the Barren Sea floor at 72 degrees north, 38 degrees east, in just 230 meters of soft sediment. That payload has now rested there for 13 months, minimally buried, minimally encrusted, perfectly recoverable by the magnetic sled techniques proven on IM-1 in the Pacific. A formal NSF proposal with 3 excellent peer reviews requested funding for this recovery. Rejected. The justification? Insufficient scientific significance. Yet no meteorite collection exists with interstellar material, IM-1, class isotopic anomalies, or objects arriving 5 months before a 2.6 kilometers interstellar visitor executing precision trajectory corrections. The suppression is precise. Every step the IM-1 expedition, CNOS analyses, NSF proposal, journal submission aligns in time to prevent recovery or confirmation. The implications of CNOS 2.5 are profound. If it was a probe, If it deployed a payload that survived atmospheric entry and landed on the barren sea floor, then 3-2 Atlas didn't just arrive at Jupiter's Hill radius blindly. It arrived already informed. The probe collected 13 months of observational data on Earth, transmitting its findings back to the main object. By the time 3-2 Atlas reached the Hill radius, every trajectory adjustment, every decision, orbital insertion, energy harvesting, or something beyond our current understanding was informed by what CNOS 2.5 discovered. We were never simply observers in this cosmic encounter. We were the destination. Consider the precision required. 4 interstellar objects over 12 years, each arriving at a time that aligns with major interstellar transits. IM-1 in 2014, first contact with Earth's atmosphere, leaving behind spherules with elemental ratios impossible in any natural nucleosynthesis process. IM-2 in 2017, coinciding with Oumuamua's transit. CNOS 2.5 in February 2025, precisely 5 months before 3-2 Atlas detection. Each event functions as a data collection mission preceding a larger object. Each leaves material on the ocean floor, yet every institution capable of recovery chooses inaction. The evidence exists, ready for retrieval, but no one moves to secure it. The IM-1 spherules are critical. Their composition, beryllium, lanthanum, uranium, cannot form naturally in known stellar or planetary environments. These elements require extremely specific neutron flux conditions, typically only found in neutron star mergers, rare supernovae, or, theoretically, artificial nuclear processes operating on a scale outside natural astrophysics. The isotopic signatures, shaped by billions of years in interstellar space, confirm extraordinary time and distance traveled, yet the ratios at formation defy natural explanation. The rejected journal submission documents CNOS 2.2 and CNOS 2.5, one referee approved with minor revisions, the second rejected, not the methodology, not the statistical analysis, not even the Monte Carlo simulations, but the interpretation. The logic of dismissal claimed improved detection could explain the high implied density, but this is circular thinking. Better instruments don't generate the population, they reveal what already exists, a density 1,000 times greater than galactic dynamics predict. This anomaly cannot be ignored. Now, reconstruct 3AU Atlas's path. Detected on July 1, 2025, at a heliocentric distance of 4.1 AU, the object was already inside the solar system. Work backward using its velocity 61 km per second and orbital elements. It crossed Neptune in late 2024, Uranus in early 2025, Saturn in March 2025, 1 month after CNOS 2.5 struck the Barren Sea. If CNOS 2.5 separated from 3.2 Atlas beyond Saturn, given a small targeting adjustment, its February 12, 2025, arrival at Earth is exact. The probe arrives first, performing reconnaissance. It either ablates completely or delivers a compact payload, an atmospheric sensor, a transmitter, or an instrument package designed to survive entry. The location is precise. Barren Sea, 72 degrees north, 38 degrees east, 230 meters deep. Minimal burial, minimal sediment accumulation, perfectly recoverable. The same magnetic sled technology used to retrieve IM-1 spherules in the Pacific could recover it. A formal NSF proposal, peer-reviewed by 3 independent scientists with excellent scores, requested funding, rejected. The rationale: insufficient scientific significance. Yet no meteorite collection holds interstellar material, no collection contains IM-1 class isotopic anomalies, and no collection accounts for objects arriving months before major interstellar visitors, executing precise trajectory corrections. The suppression pattern is undeniable. Each data point, the IM-1 expedition, CNOS analyses, NSF proposal, and journal submission aligns in time to prevent physical evidence recovery. Institutions have not merely ignored the data, they have systematically blocked it. And yet, the trajectory of 3-2 Atlas and the spherules left behind by CNOS 2.5 are public. Monte Carlo simulations can be reproduced by anyone with access to the datasets. The probes reported back. 3-2 Atlas acted on that information. We were never just observers, we were the measured environment. Every element in this puzzle points to the same conclusion: sequential reconnaissance. IM-1, IM-2, CNOS, 2.5, all precursors to a primary object, each collecting data, each providing feedback, each influencing the trajectory and actions of what followed. Recovery attempts were blocked. Evidence sits on the ocean floor. Yet the physics, the trajectories, the elemental ratios, and the timing cannot be fabricated. This is more than coincidence. 4 interstellar objects, 12 years, 2 arriving precisely in the same year as large interstellar transits, a population density far beyond natural generation, a recovery site sitting in accessible water, funding and proposals rejected repeatedly, preventing retrieval. The data doesn't scatter, it converges. And the theoretical frameworks applying von Neumann probe architecture to this observed pattern suggest sequential reconnaissance, intentional and directed. Now, let's dive into the theoretical synthesis that connects IM-1 spherules to a larger interstellar framework. The elemental ratios of these spherules, beryllium, lanthanum, uranium, are impossible to explain through natural processes in known stellar or planetary environments. But viewed through the lens of string theory and hyperspace architecture, a pattern emerges. In a 1-1 dimensional framework, energy configurations exist that are impossible in our familiar 4-dimensional spacetime. These configurations allow for artificial nucleosynthesis at a scale a Type II civilization could theoretically achieve. In other words, the ratios we see in IM-1 are not approximate, they are exact. They match the output of an intelligent process operating far beyond natural astrophysics. The implications are staggering. Each interstellar object, IM-1, IM-2, CNOS 2.5, leaves a trail of data and material that, when interpreted collectively, points to a civilization capable of interstellar deployment at a scale we can barely comprehend. CNOS 2.5's impact on the barren sea floor was not random. It delivered its payload precisely where it could be observed, measured, and ultimately ignored, at least by human institutions. The 13 months of data it collected allowed 3-2 Atlas to execute precise trajectory corrections and target Jupiter's Hill radius with full knowledge of the local environment. This is sequential reconnaissance on a cosmic scale. Each object serves as a scout, preparing the path for the next, gathering critical information about Earth and the inner solar system. IM-1 in 2014 marked first contact. IM-2 in 2017 coincided with Oumuamua. CNOS 2.5 in February 2025 preceded 3-2 Atlas. Every single event leaves material behind, yet every attempt to recover it is systematically blocked. Peer-reviewed proposals with excellent scores are rejected. Journals dismiss interpretations. Funding is denied. The pattern is too consistent to be accidental. The precision of the trajectory reconstruction is worth emphasizing. 3.2. Atlas's path can be traced backward, crossing Neptune in late 2024, Uranus in early 2025, Saturn in March 2025, just after CNOS 2.5's impact. The probe, separated from the main object, executed targeting adjustments and arrived at Earth at exactly 72.4 kilometers per second. Its payload, whether fully ablating or delivering a compact sensor, sat on the seafloor in a location precisely mapped and recoverable, yet no one acted. The instruments, the data, the evidence all ignored or actively suppressed. The data points converge on a single conclusion. This is an orchestrated reconnaissance strategy. The interstellar objects are not randomly distributed debris. They are deployed instruments, scouts gathering and transmitting information. The population density implied by the impact rates, thousands of times higher than what natural galactic ejection can produce, supports this. We are not observing random cosmic chaos. We are observing intentional placement, timed sequences, and precision deployment. IM-1 spherules, analyzed with string theory frameworks, reveal energy patterns that could only result from artificial nucleosynthesis. CNOS-25's payload was designed to survive entry and provide data. 3-2 Atlas acted on that data months later, demonstrating pre-knowledge of the environment it would encounter. Earth was not merely observed, it was measured, tested, and recorded. Every decision along the trajectory was informed by the probe's reconnaissance. The suppression of evidence, the rejection of proposals, and the dismissal of interpretations do not erase the physics. They do not erase the trajectories, the Monte Carlo simulations, or the elemental anomalies. The institutions may have ignored the signals, but the patterns are undeniable. Sequential reconnaissance, interstellar data collection, and pre-informed trajectory execution create a narrative that cannot be dismissed as coincidence. In Part 5, we will examine the full von Neumann probe architecture implied by these events. We will explore how a civilization could deploy interstellar reconnaissance at this scale, why Earth was selected as a focal point, and what the mathematical population density of these objects demands about the nature of the civilization behind them. The evidence from IM-1, IM-2, CNOS-2, 5 and 3, Atlas forms a continuous chain connecting elemental anomalies, interstellar trajectories, and predictive deployment strategy. This is not random. This is design. To understand the scale of what we're seeing, we need to talk about von Neumann probes, self-replicating instruments designed for interstellar deployment. Imagine a civilization capable of constructing a probe that can duplicate itself using local resources once it reaches another star system. Now imagine thousands of these probes distributed across the galaxy, each carrying the capacity to observe, record, and transmit information back to a central hub. That's the framework we're forced to consider when analyzing the sequence of IM-1, IM-2, CNOS-25, and 3-2 Atlas. The pattern is precise. Each object arrives ahead of a larger interstellar visitor. Each delivers a payload, either fully ablating or leaving behind material designed to survive. These payloads are strategically placed, retrievable with current technology, yet consistently blocked by institutional processes. IM-1 left spherules on the Pacific floor, CNOS-25 landed in the Barents Sea, and proposals to recover them were rejected despite scientific merit. This isn't bureaucratic incompetence. It's a repeated, measurable suppression pattern that aligns perfectly with the physics and trajectory data. The timing is critical. CNOS-25 impacted 139 days before 3-2 Atlas entered the inner solar system. This mirrors the earlier sequence in 2017, when IM-2 preceded Oumuamua by roughly 6 months. The statistical probability of these temporal alignments occurring randomly is about 6%, meaning there's a 94% likelihood that these events are correlated. In any other field of science, a 94% probability would drive major research initiatives and institutional funding. Here, It was met with rejection and dismissal. But the mathematics don't lie. The Monte Carlo simulations of CNOS-5's trajectory show it exceeded solar escape velocity by 5.5 standard deviations. Every trajectory tested is unbound. The population density implied by these impacts suggests millions of interstellar objects moving through Earth's orbit, carrying mass equivalent to 1,000 times what galactic models predict. These aren't natural scatterings of debris. They represent a deliberate, localized concentration. Earth, for reasons we're only beginning to deduce, has been flagged repeatedly. The elemental composition of the materials left behind reinforces this conclusion. IM-1's spherules are enriched in elements that require extraordinary neutron flux conditions, conditions found in neutron star mergers, certain supernova classes, or artificial nuclear processes outside natural stellar physics. The isotopic signatures confirm billions of years in interstellar space, yet the elemental ratios indicate artificial formation. This is evidence of technological intervention on a scale far beyond humanity. Now consider the trajectory of 3-2 Atlas. Using data from CNOS-25, it executed precise course corrections across billions of kilometers, targeting Jupiter's Hill radius with full knowledge of Earth's environment. Every calculation, every velocity adjustment, every orbital element was informed by reconnaissance that humans could only have observed passively. We weren't the observers, we were the target. Every object in this sequence, every material remnant, every simulation converges on this conclusion. The implications are staggering. We're witnessing an interstellar civilization capable of deploying reconnaissance probes across multiple star systems, gathering data, and making trajectory adjustments with unprecedented precision. Each impact event is a deliberate act of observation, each payload a source of information feeding back to a larger interstellar operation. The patterns we see are consistent with what a civilization operating at a Type 2 or Type 3 energy scale could achieve. Yet the institutions charged with exploration, recovery, and analysis NSF, journals, mission proposals have repeatedly denied access, ignored evidence, and suppressed physical retrieval. IM-1 spherules, CNOS-25's impact site, the trajectories of interstellar visitors all remain accessible in datasets, but untapped in terms of direct observation. The evidence is there, reproducible, scientifically significant, yet systematically left unrecovered. The story of IM-1, IM-2, CNOS-25, and 3-2 Atlas is far from over, and the final part will reveal just how much of this interstellar operation we've been unknowingly observing.